Thank you guys for joining me today. I will share with you very interesting details about steel reinforcement according to ACI, and I will start first with the minimum spacing of steel rebars. Keep in your mind, sometimes in your cross section, we have steel reinforcement in two layers. Like this, you have question with steel reinforcement in two layers, and sometimes we have only one layer. When I will decide to use two layers and when it must be one layer. Does that make sense? And also, I give you option. Once you get the area steel value from your design, I will convert this area steel to how many rebars of size whatever. So if you use number 4, I'm gonna use 10 rebars. If you are going to use number, for example, 6, I'm gonna use 7 rebars. If you use number 8 rebars, I'm gonna use 4 rebars. And I give you the full freedom to select what you want. But sometimes, if you are talking about minimum spacing requirement, we can decide which number is the best, 10 or 7 or 4. By the way, I would like to let you know that one layer reinforcement is better than 2 layers steel reinforcement. This case is better than this one. But if we have to use double layers, that's fine. But one layer is better. Why? For one reason. Your depth D is measured from the top of the concrete cross-section to the steel reinforcement. This is your D. If you have 2 layers, that means your depth will be smaller a little bit. Does that make sense? There's a very simple reason. The depth of the steel reinforcement, bigger depth means better performance for the cross section, better strength or greater strength. So if you put your steel reinforcement in 2 layers, actually the depth of the steel reinforcement, because the depth will be at the centroid, which is in between the 2 layers. So your depth will be smaller a little bit. Because if you measure from this location, will be smaller if you measure from this location. I know it's not a big deal. You are talking about 1 inch or 2 inch maximum, but will make a little difference. Does that make sense? So 1 layer is better than 2 layers. I would like to let you know what is the meaning of minimum spacing of steel reinforcement. We have expression here. One of them, I'm gonna use the greatest number. I'm sorry, the least, the greatest of, the greatest number. 1 inch, dB, which is the diameter of the steel rebar. dB means the diameter of the steel rebar. Keep in your mind, if you are using rebar number, for example, 5, this rebar has a diameter. You can find this diameter from the table. For steel rebar number 5, I can say for number 5, the diameter is 0.625 inch. This diameter is 0.625 inch. Or 4/3 D aggregate. The third value, as you know, for any concrete, we have 3 main ingredients. We have cement, we have coarse aggregate, and we have sand. This coarse aggregate in form of gravel, stones, whatever, the maximum size of one particle. Go ahead and find the biggest particle in this coarse aggregate. This coarse aggregate, The biggest size is called the maximum aggregate size. Does that make sense? D aggregate means the maximum aggregate size. How can I figure this out? We have something called the sieve analysis. You will learn more about this in soil mechanics next semester, but we have something called the sieve analysis. This sieve analysis will be used to figure out what is the maximum size of these aggregates. The biggest size, 4-inch, 6-inch, 2-inch, you need to multiply this size by 4 divided 3. Why? I have a concern about the size of the aggregate. Keep in your mind, the minimum size is, the minimum spacing is the clear spacing between this rebar and the next rebar. To make sure your concrete can go through between the two rebars, we have to make sure the maximum size, the biggest size of the coarse aggregate is smaller than the spacing to make sure the concrete can go through between the two rebars. That makes sense? So keep in your mind, when you are putting your steel rebar as one layer, for example, at the bottom of the cross section like this, keep in your mind, we have minimum spacing, clear minimum spacing between this face and this face. This spacing must be the biggest value, 1 inch, or diameter of one rebar, or 4 divided 3 maximum aggregate size for the coarse aggregate. So for example, if we are using the number 5 and the maximum aggregate size is 1 inch, so we have 3 values. 1 inch, one of them, and the diameter of the steel rebar is 0.625, and the 4 divided 3 times the maximum aggregate size, which is 1 inch, I got 1.33 inch. So I'm gonna use the minimum spacing, clear minimum spacing between the steel rebar must be the greatest value of these 3 values, which is 1.33 inch. Does that make sense? That makes sense. This is the minimum. We cannot put steel rebars with a spacing, clear spacing, smaller than this value. If you put this smaller than this value, that means you are against the rules of the ACI, and we should expect more problem, especially when you are pouring concrete. I would like to highlight this using AutoCAD. Let me assume we have a cross section with depth, total thickness, overall depth 30 inch, and width equal 16 inch. And we have a steel reinforcement here at the bottom equal, for example, 6 number 5 rebar. And we have stirrups. As you know, we learned this last meeting, how to figure out the required stirrups. So I'm gonna assume we have stirrups. These stirrups will be number 4 every 6 inch. I would like to make sure the minimum spacing is good. The minimum spacing between the steel rebar, we have here 6 rebar. Like this. So to make sure everything is good, I'm gonna use AutoCAD. So I will start first to draw a rectangle with dimension 16 times 30. So we have 16 times 60 times 30. Keep in your mind, after the concrete cross section, we have here something called concrete cover. Do you agree? This concrete cover can be 1.5 inch, maybe 2 inch, maybe 3 inch. It's up to you. I'm gonna use 2 inch. So I have offset O enter, and the distance will be 2 inch, 2 enter. Then I will start to draw the stirrups. Keep in your mind, this stirrup has thickness, because this stirrup represents a steel rebar, and this steel rebar will have diameter. Do you agree? So it's not one line without thickness. No, it's something with a thickness. The thickness equals the diameter of this rebar, number 4. So if you open your table for number 4, we have a diameter equal 0.5. So I will do offset 0.5. This represents the thickness of your stirrup. We cannot bend the steel rebars like sharp bend, so I will use fillet with a radius equal at least 0.5, like this. That makes sense? So your cross section is the width is 16. I put concrete cover from this side and the concrete cover from the other side. And keep in your mind, the stirrup has a thickness. The thickness of this stirrup equals the diameter of your steel rebar for the stirrups, which is number 4. Number 4 has a diameter equal 0.5 inch. So far, so good? Anybody has any questions so far?
No, sir.
Okay. We have a command in AutoCAD called donuts. It's not donuts to eat, but something to draw. Donuts, the inner diameter will be 0. The outer diameter I will use, because we are using number 5 for steel rebar. So number 5 has a diameter equal 0.625. So the outer diameter will be 0.625. And then I can put the steel rebar here. This is the first one. And this is the last one. That makes sense? Keep in your mind, this circle represents the steel rebars, which are number 5. We should put 6, but I started with the first one and the last one. Number 5. Number 5 has a diameter equal 0.625. So if you would like to draw the circle represent number 5, this circle must have outer diameter equal 0.625. Does that make sense? I still need to put more spacing. So you can measure what is the distance between the center of this one and the center of this one. How much is the spacing? 10.4 inch. 10.4 inch. I need to arrange the remaining rebars between this distance. So how many spacing to put the remaining 4? I think 1, 2, 3, 6 spacing. So I will divide this number by 6, will give you 1.7. So if you start to make copy and make perpendicular, 1.7, 3.4, 5.2, 6.9, and 8.6. There you go. I arranged my steel rebars with equal spacing. With equal spacing. One more time. I started to draw my cross section, which is 16. I can make this one bigger. Just a second, modify properties. Text the height, we can make it 1. Yeah. And your number, primary unit, just we need only, not this one. We need only, yeah, this one. Okay. Looks good. And also I can adjust the arrows to be oblique. And I don't need extension off and off. And I can make the size bigger. 1 is good. Okay. So this one is 16 and the dimension linear. This one is 30. I can make match. I will highlight this one and we have match here. Where is this one? Match properties. To make this one looks like this one. Anyway, after you draw your cross section, the outer cross section with a 60 by 30, I make offset for the concrete cover and another offset for the diameter of the stirrups. Then I put the first rebar and the last rebar. And I measured the distance between the center of this rebar to the center of this rebar. I found this distance equal 10.3. I divided this distance by the number of spacing and then make copy or array or whatever the command to put your rebars in equal spacing. Keep in your mind, I have to make sure that just a second, shift, right click. I have to make sure that the spacing, the clear spacing between this edge and this edge, right now, this distance equal 1.16. This distance equal 1.16 inch. Clear distance between this rebar and this rebar. 1.16. Unfortunately, you need clear distance equal 1.33. So the minimum spacing between the steel rebar does not satisfy the requirement of ECR. In this case, I will decide to make 2 layers of the steel reinforcement. Because if you moved at least 2 rebar, that means I need to put here not 5, but I need to put 3. Does that make sense? So the distance, which is 10.3, will be divided by 4 spacing, which is 2.5. So I will put copy 2.5 and the 5 and the 7.5. There you go. How many rebars right now we have? No, we have 7. We should have how many? 6. So we can remove this one and your spacing will be 10.3 divide 3, 3.4. So copy 3.4 and another one from this side, 3.4. There you go. In this case, your clear distance between the edge of this rebar and the edge of this rebar, this distance will be DI enter between this one and this one equal 2.8 inch. We are good. 2.8 is good because it's greater than the minimum spacing, which is 1.33. So how to put your steel reinforcement or to arrange your steel reinforcement is not 1 second. No, you have to try. First of all, I tried to put the steel rebars as one layer, like this. Unfortunately, I found the distance between the edge of this rebar and the edge of this rebar is smaller than the minimum spacing. So I decided to use double reinforcement. Keep in your mind, if you decide to use double reinforcement, your number, if you put something on this side, you have to put another one on the other side. It's not accepted to find a steel reinforcement like this, and you put only one steel rebar here. At least you have to put two. And also, I will start from the edge, this side and this side. Don't start from the middle. I mean, if you have steel rebars at the first layer, don't start with the second layer here. It's not good. I have to start from this edge and one more on the other edge. If you have more, you can put it inside. But the first priority is the edge. At this edge and this edge, this side and this side. Does that make sense? Don't start with the middle. Anybody has any questions so far about the minimum reinforcement spacing?
No, sir.
If you would like, this is the final cross section. If you would like, I can make this stirrups more thicker, like this. And I can write, if you want, we have how many? 2, 4, I put 7, but anyway, they should be 7. So assume we have here 7, I'm sorry. Looks like I did this mistake. I can write, we have 7, number 5. I can make it bigger by scale. You should be a professional in AutoCAD to be able to write what you want. Maybe I need to make it bigger also, like this, and move to adjust it here. Also, I can draw a line to this one, like this, and write, I can copy this one here and adjust it. We decided this one is number 4. Every, what is the inch? Do you remember? 6 inch. There you go. This is how to draw your cross section of the beam. Does that make sense? This is how to draw your cross section of the beam. Okay, this is the first slide, which is talking about minimum spacing of the steel reinforcement, and this minimum spacing can force you or can enforce you to decide to use double reinforcement. However, the single layer is better than double layer. Second point, I would like to talk about something called development length. If you remember, if you have a beam by a column, we should have bending moment looks like this, and the tension will be at the top, and we have compression at the bottom. I don't care about the bottom right now, but my concern is the top. We have a steel reinforcement here to cover the tension at the top. I cannot end up the steel rebar at the face of the column or the support. I have to extend it more. And maybe I have to put another more here, leg, looks like this shape. Why? As you know, your steel reinforcement is not working alone. Your steel rebar is working with the surrounded concrete. We have concrete around this steel rebar. So we must have an satisfactory or a satisfactory or enough length or bond between the steel rebar and the surrounded concrete. If your edge or face of the column is located here, so your bending moment diagram looks like this. So we cannot end up the steel rebar at the face. We have to embed the steel rebar beyond the end of the bending moment diagram. This length is called development length to make sure we have enough bond between the steel rebar and the concrete. Keep in your mind, under the analysis of your cross-section, this steel rebar will have capital T and your concrete will have capital C. So this rebar has tension. If we don't have enough length embedded in concrete, this steel rebar can slip from the concrete. If this happens, we don't have composite, we don't have steel working together with concrete. So failure will happen. So if you read what is the meaning of development length, defined as the amount of reinforcement length needed to be embedded into concrete to establish the desired bond strength between the concrete and the steel. If you see the original drawing, we don't have enough development length. So if we have tension in this steel rebar, capital T, I promise the slip will happen between the steel rebar and the concrete. You must extend this steel rebar more, and maybe you have to create a leg like this. To make sure we are good, this length is called LD, development length. Does that make sense? Also, at the middle of the beam, your steel rebar must extend to the support with a development length also to make sure the tension in this steel rebars is embedded in concrete. Bar tension force must be transferred from the bar or the rebar to the concrete through the bond stress. The distance over which this transfer takes place is called development length. This development length can be defined as the minimum. This is the minimum. You can provide something more, but you cannot be smaller than this length. According to ACI, we have this equation can give you what is the minimum development length according to ACI. This one or this one, 12-inch or this one. So I'm gonna use the biggest value, this one or this one, biggest value. So I have to figure out the first equation, how much, and the second one give me 12. I'm gonna use the biggest value. Your development length for tension, your steel rebar is under tension, so I need to extend it more inside concrete. This development length in tension equal 3 divided 40 time F yield divided by lambda time F square root F prime C time psi T psi E psi S time dB divided by this expression. CP plus KTR divided by DB. It's a very complicated equation, but we have to consider this. So for example, I will right now work with you to draw this cross section. So this cross section, which is 30 feet, but we cannot draw 30 feet. I have to consider a 30 inch in feet anyway. So I will start with a line like this. I can change the color to be red, and I can change the style to be center. I can modify the properties to be point one, maybe. It's not a big deal. Anyway, so the span of this beam equal, for example, is 20 feet. So we have 1, 2, 3, 4 span. And this is your beam. I can make offset for the column 1 feet. Okay. 1 feet from this side. So your beam depth is 30 inch, 30 divided 12 equal 2.5. 2.5 offset. So then I can make match properties for this one. Don't worry, we'll see what will happen. Then I can do trim. Go. So the span for this beam equal 20 feet, which is the distance between center line to center line for these supports. That makes sense? So if you would like measure linear between this one and this one, this distance equal 20 feet. I can adjust this dimension to make it bigger. For arrow to be oblique. This one also oblique. And make it bigger. 1. And also for the text. Let me first just only 2 numbers, decimal number is enough. For the text height, it will be 1. There you go. And also dimension, linear between this one and this one, between this one and this one, and between this one and this one. I can make match. So this one will be the same properties. Here is your beam. Here is one of your beam. If you remember, we have at this location steel reinforcement at the top. That's right. Do you remember that?
Yes, sir.
I would like to remind you, if you have a beam and here is a support, and there is a second support, and there is a third support, and there is a fourth support, whatever. If you remember, we have bending moment looks like this. That's right. Keep in your mind, this length also for this one, and this one, this one, and this one, this one. This length approximately from 20% 0.2 until 0.3 of the span length. If this span length equal 20 feet, approximately this length until the bending moment diagram is over, approximately we can decide it 0.2 L. So 0.2 times 20 means 4 feet. So offset 4 feet, your bending moment diagram will be ended here. And also 4 feet from the other side, your bending moment diagram will be ended here. So this length from here to here represent this total length. This total length. This total length. This total, no, this one will be 0.2 only. So this one will be, I will extend this one up here and make offset 4. Only 1 4 from this side. Does that make sense? So keep in your mind, your steel rebar, I will do offset and I will leave 2 inch. 2 inch means around 0.2 feet. 0.2 trim. And I can delete this one, and I can delete this one. This is the required steel reinforcement at the top. This is the required steel reinforcement at the top. I'm sorry. Does that make sense? That makes sense? So, wait a moment. Here you go. This one and this one ended up at the end of the bending moment. I stopped the steel rebar at the end of the bending moment, at the end of the bending moment, at the end of the bending moment. This is not true. You have to extend your steel rebar a little bit more. A little bit more. So one more time. This end is at the end of your bending moment diagram. This is at the end of your bending moment diagram. According to ACI, we have to extend it a little bit equal to one of these. Greater than or equal, one of them. D, which is the depth of your cross-section, 12 diameter of the steel rebar, or span length divided by 16. The clear span length divided by 16. Your steel rebar cannot be ended at the end of the bending moment. We have to extend it a little bit more to be embedded in concrete by one of these, the biggest value. Depth of the cross section, 12 diameter of the steel rebar, or span divide 16. If you go back, what is the clear span? the clear span between the columns equal 18 feet. So 18 feet times 12 to be an inch divided by 16. I got here 13.5 inch. This one, since we are using a number 5 and the number 5 stereo bar has a diameter 0.625, this diameter must be multiplied by 12. So this value will give you 7.5 inch. And the depth of the cross section, the total depth is 30. If you subtract 3 inch or 2 inch, it will be 28 inch. Which one is the biggest value? I'm gonna use the biggest value is your depth, which is 28. That means I have to extend this stereo bar more 28 inch, which is 2.3 feet. So I have to add here 2.3 and another here 2.3. So I can tell you what will be the total length of the stereo bar. I need to order stereo bar with a length equal 14.6 feet to be over this column. Does that make sense? Polyline, I can make it one piece like this. So this stereo bar will be, you can write here the length of the stereo bar. Equal, how much? Do you remember? Distance, 14.6. I can make it bigger, scale. There you go. So from your design, you decided that I need here at this location, for example, at this location, for rebar number 5. You did in your exam. So how to figure out the length of this stereo bar to be over this column? This is how to do this. First of all, where is the end of your bending moment? The end of your bending moment at distance equal 20% of the span length, 20% of 20 feet from this side and 20% from the other side. This is the end of your bending moment. I need to extend my stereo bars more than these two ends. How much? Based on ACI, I have to extend it one of these, the biggest value. Depth, the depth of the cross section, 12 diameter of the stereo bar, or clear span divided by 60. Then I can decide the length. Also, keep in your mind that this distance between the end of the stereo bar and the face of your column, this distance will be or must be equal or at least greater than the development length. This one or this one, at least 12 inch or this value. So the development length is the length of the stereo bar from the face of the column to the end of the stereo bar. So we have two limits right now we have to satisfy. The first one, your stereo bar must go beyond or behind the end of the bending moment by a value. This value, according to ACI, is one of these. This one or this one or this one, the biggest one. Once you satisfy this limit, you have to satisfy another limit, which is the distance between the end of the stereo bar to the face of the column. This distance must be at least development length or greater. So we have right now 6.3 feet. Hopefully, this length will be smaller than this value to be Good. Just to give you a hint, I will not go through this equation in more details, but this lambda depends on what is the type of concrete. Sometimes we have lightweight concrete, sometimes we have normal concrete. For normal concrete, lambda equal 1. If yield, what is the yielding stress of your steel rebar? F prime C, what is the characteristic strength of concrete? We have psi T. This psi T depends on the position of your steel rebar, but most of the time we are using it 1. Psi E based on the epoxy. Sometimes we have a specific type of steel rebars with epoxy to increase the bond between the steel rebars and the surrounded concrete, but most of the time we are using uncoated. We are using a normal steel reinforcement without epoxy, so the value will be 1. Psi S based on what is the size of your steel rebar. Keep in your mind, bigger size means bigger development length, because you have a very big steel rebar, so that means we have to provide very longer development length. So based on the size, number 7 or larger, we are going to use 1. For number 6 or smaller, we are going to use 0.8. And the dB is the diameter of the steel rebar. If you multiply these numbers together, you can get the development length. This development length must be smaller than, or at least equal the this length. So I believe 6.3 feet will be enough. Does that make sense? So this is how to put your steel rebars over the column. And keep in your mind, this steel rebar at the end, at the column, the end column, must be go through the column by a development length. So this length to here and here, this length of this part and this part behind the edge of the column must equal the development length from this equation or this one, 12" or the value from this one. Does that make sense? What you did here will be the same and the same here. And what you did here will be the same here. That makes sense? This is how to put your steel rebars for the top reinforcement. At the bottom, we will put steel reinforcement like this. But keep in your mind, your steel rebar must extend to the columns. I totally understand that your moment here, from here to here, from here to here. So at the column, we don't have moment, but you have to extend your steel rebar to the end of the column from the other side, like this. Does that make sense? And also for this one, like this. Does that make sense? So if you have another steel rebar from this one, keep in your mind, I can make it higher like this. So this steel rebar must be extended to here. And this steel rebar must be extended to here. Does that make sense? So you can decide what is the length of your steel rebar. The same here, offset 0.2, I'm sorry, 0.2. And this one is 0.0. So this one will be extended to the end, the other face of the column. And this one, the same. And this one to the end. Does that make sense?
Yes.
And this one will be the same here. You can make copy. And you can make copy for this one. Like this. And you make copy for this one. Like this. And also you can make copy for these. This is called shop drawing. Shop drawing means you are providing more details about the lenses of your steel bars, so the worker can look to this drawing and decide, yes, I need to cut the steel bars for lenses 14.6 feet. And you have to write also here, it's very important. You have to write here, what is the number? So it's for number 5 rebar. So you can make it like this better. So the worker can say, hey, I need 4 pieces with number 5, each has a length equal 14.6 feet. Does that make sense? Does that make sense? And also you can measure what is the distance between this one. So the distance equal 22 feet. So I can make copy from this here. And the length can be adjusted to 22 feet. And the number is not 4. For example, it's 7. That makes sense? So the worker can say, okay, I need to prepare 7 rebars, each size number 5 with a length equal 22 feet. And what will be the length here? Maybe a little different, 21.8. If you would like to cut them 22 feet, we can make a leg here, a little leg here up, so the total length will be 22 also. Does that make sense? One of you will say, hey, sometimes we don't have this enough length, 22. Maybe the maximum length I have in my area is 12. So how can I figure out the total length, a total length equal 22? The maximum length I have only 12. This 12. So how can I put another 10 feet? Like this. So the total will be 22. In this case, we can make a splice. In this case, we have something called a splice. There you go. Lab splice. Lab splice means it's the length that 2 rebar pieces can overlap to create a bond as they are continuous. They are one rebar. Does that make sense? In this case, we don't have enough length for the steel rebar. We can make a splice between a piece and another piece, but make sure this splice has a limit. According to ACI, this limit mostly this one. 12-inch minimum or 1.3, the development length that you calculated from here. 1.3. So from AutoCAD, I have to extend this length a little bit. So this length is called the splice length because you are connecting between 2 steel rebars. Why? Because we don't have enough length for one rebar to cover the whole length. So I can make a splice between 2 pieces, but keep in your mind, this splice or this overlap length has a limit according to ACI. This limit, 1.3, this development length, or 12-inch. I'm gonna use the biggest of any. Does that make sense? And sometimes this is splice in tension. Sometimes we have a splice in compression. We have another limits for the case if you have a splice in compression, but mostly in tension. Does that make sense? So this is what I would like to highlight today. The first point I highlighted, how to use AutoCAD to draw your cross-section. How to use AutoCAD to draw your beam reinforcement, main reinforcement. I'm talking about main reinforcement. The second point I covered, what is the minimum spacing between your steel bars? Net spacing or clear spacing. Because the decision behind this minimum spacing is you can decide 2 layers or 1 layer of steel reinforcement. Also, I talked about development length and what is the meaning of development length. And also, I talked about the steel reinforcement when or where, I'm sorry, you need to stop it. We cannot stop the steel reinforcement by the end of the bending moment, but we have to extend it a little bit. After you satisfy this requirement, keep in your mind from the face of the column to the end of the steel rebar, we must have at least development length. You have to satisfy both of them. By the end, you can draw your stirrups just to align like this, and you can make offset 6 inch, which is 0.5 feet, like this. So these are called stirrups. And you can make copy. I will not draw all of them, but at least some of them. Does that make sense? Some of them, at least. And then you can draw a line like this and like this. And make a line like this. And make copy. Just you highlight it. I'm highlighting these vertical lines. And I can write here. You don't need to write from scratch. You can take one from these and put it here, and you can adjust it. We have, for example, number 4 every 6 inch. Or you can make spacing between them like this. So if you look to this sketch, you can understand the what exactly you need. I forget to put this steel bar here. Just copy. And also here and here. So I can understand from this one, I have stirrups, number 4 every 6 inch along the total length of the beam. I can understand I have to provide a steel reinforcement at the bottom with length equal 22 feet, 7 rebars, number 5. And this rebar will start from the second face of this column to the end of this column. That makes sense? So I have another piece here from this face of the column to this face of the column. The length of this rebar is 22. I need 7 pieces and the number 5. So I can read everything I need from this drawing.